Alright, so we're going to start out with number one, where we're trying to figure out whether this is symmetric to the five things. And so we start out with the origin, where we change x to be negative x and y to be negative y equals 5. Two negatives make a positive, so the answer for the origin is yes. For the x-axis, we change y to be negative y. And so we only have one negative, so the answer for that one is no. For the y-axis, we change x to negative x. So we got negative xy equals 5. Once again, only one negative, so the answer is no. When we have the line y equals x, we switch y and x, and because multiplication is commutative, we got the answer of yes again. And for y equals negative x, we change x to be negative y, y to be negative x. Two negatives make a positive, xy equals 5. So for this particular problem, we have three s's: the origin, the y equals x, and the y and y equals negative x. In problem number 2, we have the origin. We got y equals negative 2x squared, or negative 2 over x squared. So when I switch negative y equals negative 2 over negative x squared, that negative should be inside the parenthesis. Anyway, so we got negative y equals negative 2 over x squared. The two negatives can be positive, but we still don't get back to our original, so the answer here is no. When we do the x-axis, we change y to negative y. Once again, we can change the two negatives to a positive, but we still don't get back to our original, so the answer here is no. For the y-axis, we change x to negative x. Well, when we square something that's negative x, it becomes positive, and so that answer is yes. I'm going to move this up so I have some more space. When we do the line y equals x, we get switch x equals negative 2 over y squared. And since the y is squared and the x is no longer, the answer is no. And y equals negative x, we get negative x equals negative 2 over negative y squared, which is negative x over negative 2 over y squared. And once again, since the y is squared and not the x, the only thing that worked here is y equals negative 2 over x squared for the y-axis. X equals y squared plus 3 for the origin. Negative x equals negative y squared plus 3. And we got a negative in front of the x, so the answer here is no. X-axis, we change y to negative y. So when we square it, we get y squared plus 3, and the answer is yes. For the y-axis, we get negative x equals y squared plus 3. We have that extra negative, so the answer here is no. For y equals x squared plus 3. It's never getting back. And for y equals negative x, so the answer was no. X becomes negative y equals negative x squared plus 3. No getting back from that. The only thing we can do is change this negative x squared to be positive x squared. Alright, we're going to do 4, 5, 6, and 7. A negative on the outside. We always say that it's a reflection. And that's going to be a reflection over the x-axis. When it's on the outside, it flips. Remember, that makes the y's change. So it will flip down. And this is going to be to the left 3. In problem number 5, we have the absolute value of x and 4 absolute value of x minus 2. That's going to be right 2. The 4 on the outside is vertical because it's on the outside. It's a stretch, and the factor is 4. Alright, for this one, the plus 5, that's the one we like. It's plus 5. This negative x is a reflection, and because it's inside, it's a reflection over the y-axis. And for number 7, we have f of x equals the square root of x, and g of x equals the square root of x over 3. And so this is going to be a horizontal. Because it's divided, it's going to be a stretch factor of 3. And the second page will be on the next video.